we have been discussing about the attitude dynamics. So, in that context, we have started with the torque free rotation of rigid body. So, let us consider the case where a cylinder is given this E1, E2 and E3 is the inertial reference. So, as we have done in the last class, this is the inertial reference frame and then the body x is to be oriented with respect to this. So, the last time we saw that this can be oriented by first rotating, this body can be oriented with respect to this inertial reference frame in the way it has been right now put, by first rotating by angle psi. So, psi dot is in this direction and then this also rotate from this place to this place. So, this we can show by dotted line, this is the angle psi, this is your E 2 prime and E 3 prime is here in this place itself. Then we rotated about this x by angle theta. The next rotation we are giving, this is about this x itself and this rotation is by theta. So, theta dot will be in this place and this will rotate from this place to, say it will rotate something like this by angle theta. This is coming out of the plane. So, this will also move. So, this is moving in one plane, E 2 prime and E 3 prime, it will move out and it will go from here to here. So, this is your angle from here to here, this is your theta. And the final rotation we gave about this itself by angle phi. So, phi dot is in this direction, and once we are rotating by angle phi, so we have to constitute one plane now. So, let us say the plane we indicate so this line is showing one plane in which this was your E1 prime. So, in this plane this point will move from this place to somewhere else. So, here we can name this point as E 2 double prime and here we will have itself E 2 E 1 double prime, because the rotation is given in this place itself, and E 3 double prime can be indicated here in this place. Now, once we next rotate about this x, we are giving a rotation like this. So, if you rotate by phi, so it will, this line will move from somewhere here to, let us say it is moving to this place. This is the angle phi and this will move away from this place to here, and this we can show by angle phi, and the final values are here this notations are E3 triple prime and E3 triple prime, okay. And this is E2 triple prime, E3 triple prime, and this point will designate as E1 triple prime. So, the notation that we have used, it is a very important. So, this is our final body X orientation. So, this is basically your E1 cap, this is your E2 cap, and finally, in this direction itself you are getting E3 cap. So, a body of we are using right now for body of revolution to ensure that the axis that we are choosing. So, those are the axis of those are the principal axis. So, that the off diagonal terms will be 0 in the equation of motion. So, finally, for this body, the same Euler equation we can use, which we have developed earlier. So, using Euler's dynamical equation. So, we wrote the equation in this way. This is the inertia matrix. I times omega dot plus, and we used a term capital omega and this we wrote as the T. This is the torque applied. So, if T equal to 0 means all the elements in this are 0. Okay. So, therefore, writing in expanded notation I 1, I 2, I 3. This was 2 by 3 0 0 and finally, here omega 1 omega 2 omega 3. So, this is equal to 0 0 0. Okay. So, this is our Euler's dynamical equation in which the torque applied is set to 0, because now we are considering the torque free rotation of a rigid body. So, now for the case of a cylinder, here we are taking the I 1 in this. So, final body X is this one E 1 cap, E 2 cap and E 3 cap, and the principal moment of inertia X these are I 1, I 2 and I 3. Okay, these are the principal moment of inertia. Principal moments of inertia along the 3 body axis. So, I 1 and I 2, because they are equal to each other, this we set as I, and I 3 we can write as I 0. Okay. So, with this notation, from here this we can break it down and write separate equations. So, the first one will give I 1 times omega 1 dot, and from here if you break it out. So, this will give you omega 3 times I 2 times omega 2 plus omega 2 times I 3 times omega 2 times omega 3 times I 3, this is equal to 0. So, we will put here I 1 and I 2, we are already setting it as I. So, I times omega 1 dot omega 2 times omega 3. So, omega 2 times omega 3 times I plus omega 2 times omega 3 times I 0 equal to 0. We are using the fact that we have set I 1 I 2 equal to I and I 3 equal to I 0. And little bit rearrangement we can do here, omega 2 omega 3 I 0 minus I, and this we let us write this as the equation number 1. Okay. Similarly, the next equation, by expanding this we can write the next equation. So, total we are getting 3 equations from here. So, the next equation you can write as multiply the same thing I 2 times omega 2 dot, these elements are 0. So, they will be 0. So, I 2 times omega 2 dot and then the rest of the terms it will appear as omega 1 times omega 3 times I 1 minus I 3, this is equal to 0, and I 2 and I 1 we need to replace by I. So, this is omega 2 dot plus omega 1 omega 3 . So, by rearrangement we can write this is our equation number 2. Next we take the third equation. So, third equation similarly we can expand and write it here. The final equation I 3 times omega 3 dot okay, putting I 3 equal to I 0 omega 3 dot minus omega 1 omega 2 I 1 equal to y, I 2 is also equal to y. Okay, so, this implies I 0 times omega 3 dot plus so, here you see this is I minus I equal to 0. So, this term becomes equal to 0. So, what we get from this place I 0 times omega 3 dot equal to 0, and this implies omega 3 this is equal to a constant, and let us say this constant we denote by n. So, this is my equation number 3. Now, we know that omega is a vector, that is omega equal to omega 1 E 1 cap plus omega 2 E 2 cap omega 3 times E 3 cap. So, these are the body components. The components of omega are along the body axis. And what we are getting that omega 3 equal to omega 3 is a constant. So, we will have omega 1 E 1 cap, omega 2 E 2 cap plus n E 3 cap. Now, the angular momentum we can write as I 1 omega 1 E 1 plus I 2 omega 2 E 2 plus I 3 omega 3 E 3. Okay. In the absence of this, we have written for the off diagonal terms are 0. Okay. So, therefore, what we get I 1 and I 2 are equal. So, we can take it outside and put here as I. These two terms can be brought here. So, omega 1 E 1 plus omega 2 E 2 cap plus I 3 is I 0 times n E 3 cap. So, now look into this equation carefully. What we have done here in this H, can we write this as say A times omega 1 E 1 cap plus omega 2 E 2 cap and plus this quantity we write as B times omega 3 cap, where A equal to I and B equal to I 0 n. And obviously, here the same thing we have done in this place also. So, and let us indicate this as a vector omega t times E t cap, okay, because these are the two vectors along the omega 1 E 1 is a vector, omega this E 2 is a vector. So, we have suppose E 1 is a vector and this is E 2 is a vector. Okay. So, the this is multiplied by omega 1 and if you multiply this by omega 2, not the cross product, these are not the cross product here. Okay. So, the resulting vector, it will be in the same plane as in the plane E 1 and E 2 are there. Okay. So, this vector we can write as E t cap times, say the omega t is the magnitude of this vector and E t indicates its direction. So, this becomes n times E 3 cap. So, the same way here we can write as this is A times omega t times E t cap plus B times E 3 cap. Now, look into this equation and this equation. In these two equations, you have this part is simply a scalar, here this is a scalar. Okay. This part is a scalar, this part is a scalar, and both are multiplied by E t cap and E 3 cap, E t cap, E 3 cap. So, what does it say? It simply implies that you have two vectors E t cap and E 3 cap, they are orthogonal vectors. So, if you multiply some quantity like the A omega t and times E t cap plus B times E 3 cap, okay. So, it will constitute a vector which will be appearing as, let us say this vector we write finally, this is basically we are writing as H, okay. This is your H vector. So, this is your H vector here, and the omega vector you have indicated as omega t times E t cap plus n times E 3 cap. So, the omega vector it may appear like this. What is the important thing here? This vector and this vector, they are coplanar, this constitutes one plane, and a linear combination of these two vectors, okay, it will be lying in the plane constituted by E t and E 3. Therefore, omega and h both are coplanar. So, what we conclude? The conclusion is, we conclude that omega and h are coplanar. Okay, this is an important conclusion which we are going to use later on. Omega and h, they are coplanar. Okay, next we take the equations that we developed, equation number 1, equation number 2 and equation number 3. So, now considering the equations 1, 2 and 3. So, what we do? We will differentiate this equation first. Okay, so, if we differentiate this equation number 1, so we will have I times omega 1 double dot plus omega 2 dot omega 3, remember this is constant and we are writing this as n. So, simply we will write here as n. Okay, omega 3 we are replacing by n. So, omega 2 dot times n, and this is equal to 0, we have missed earlier. So, we put a 0 here in this place, I 0 minus I, this is equal to 0. Okay. Next we take this equation number 2. In this we have the omega 2 dot available, omega 2 dot is appearing. So, omega 2 dot we can insert from equation number 2. So, inserting omega 2 dot from equation 2 into the above equation, I times omega 1 dot 1 double dot and omega 2 dot will be, we need to replace this. So, it will appear with a minus sign here. Okay. So, omega 2 dot will be omega 1 times omega 3 divided by I 3 times I minus I 0. So, this is omega 1 times omega 3, and naturally omega 3 will replace later on by n in one more step. So, this is n times I minus I 0 divided by I, and this quantity is equal to 0. So, here we carry out one more step and write this as omega 1 times n square I minus I 0 divided by I equal to 0. If we do little more manipulation in this by rewriting in this way, n square times omega 1 I 0 minus I, we are taking the negative sign out from this place by taking negative out of the bracket by I, this is equal to 0. Okay, one more thing, here we have I minus I 0. So, I 0 minus I was already present. So, we need to multiply here one more term. Okay. So, omega 1 omega 3 times n, that we replaced from this place, and I minus I 0 we need to bring in this place. So, we will put here as I minus I 0 times I 0 minus I. This is multiplied by I 0 minus I. Okay. So, while we are putting it in this format, this term will become a square. Okay, so, what we have done, that we have got this equation I times omega 1 double dot plus we can write here the term n square times this quantity which is present here, okay, as lambda. Say we are putting lambda for this. So, lambda times omega 1 or let us make this as lambda square. Okay, I will carry out this step again once more. This is I times omega 1 double dot plus omega 2 dot times n times I 0 minus I, what we wrote in the equation number 1. This is the equation number we have chosen. Okay. So, omega 1 double dot, this becomes omega 2 dot n times I 0 minus I divided by I equal to 0. Okay. Let us go step by step, because some of the terms we miss. Okay. The next equation is, we are using the omega 2 dot from this equation. So, omega 2 dot, this is minus omega 1 times omega 3 times I minus I 0 divided by I. Okay. So, here we can put omega 3 is equal to n in this step, I minus I 0 divided by I. Okay. Now, we will use this equation, and we will name this equation as equation number 4 and this as equation number 5. Okay, so, you can see that what we were working out. So, we missed out the square term here. So, this is also coming with divided by I here. So, this is divided by I. So, ultimately you are getting the square term here in this place. This is a square term. So, I am cancelling out this page, and what we have done is a fresh derivation we are putting in, and this is 39. Okay. Now, inserting equation 5 into equation 4. Equation 4, this gives us omega 1 double dot minus omega 1 times n square I 0 minus I divided by I times I minus I 0 divided by I equal to 0, which can be rearranged to give omega 1 double dot plus omega 1 times n square times I 0 minus I divided by I square equal to 0, and in compact notation we can write as lambda square times omega 1. This is equal to 0, where lambda is equal to n times I 0 minus I divided by I. Okay. Now, this equation is correct and this we name as this equation as this is our sixth equation. Okay, so, you can recognize this is the equation of a simple, this is equation for simple harmonic motion. So, this is equation for simple harmonic motion, simple Okay, so, the way we proceeded, we got one equation which is in the form of simple harmonic motion. Now, we can take the equation number 2. Okay. The way we have done the differentiated equation number 1. So, similarly, we differentiate equation number 2, differentiate equation 2. So, this will give you I times omega 2 double dot plus omega 1 times omega 1 dot times omega 3. Omega 3 is a constant, this is a constant and therefore, we just put for this as n. Here we can note it down, omega 3 is equal to n. And this is I minus I 0, this is equal to 0. Now, we need to replace omega 1 dot in this equation. So, omega 1 dot we can replace from equation number 1. Okay. So, in the equation number 1, this is the equation number 1 we have written earlier. So, omega 1 dot this can be written as minus omega 2 times n I 0 minus I divided by I. And let us name this equation as, this is equation number 7 and this is equation number 8. So, inserting equation 8 into 7. So, this will imply I times omega 2 dot minus omega 2 times n square I minus I 0 times I 0 minus I divided by I equal to 0. We bring this I on the right hand side. So, omega 2 double dot and the minus sign we can take out from this place, this minus sign we can take it out and put it in the format where it will appear as I 0 minus I. So, this becomes a square divided by I square equal to 0. And the compactly in the same way, because we have already defined lambda equal to n times I 0 minus I divided by I. So, using that notation we can write this equation as omega 2 double dot plus lambda square times omega 2 equal to 0, and this is our equation number 9. Okay, so, we have got two harmonic equations. Now, this can be solved easily. So, omega 1 can be written as solving equation 6 and 9. This gives us omega 1 is equal to a cos lambda t plus b sin lambda t. Similarly, omega 2 we can write as c cos lambda t plus d sin lambda t. So, it simply indicates that the body component, the angular rates of the body component, they are nothing but they can be represented by a by these equations. So, because these rates itself they constitute the simple harmonic motion. Okay, so, once we are representing in this format, now to get little more informations, we need to do some more processing. So, we get back to our equation number 1 and 2. Okay, so, these are our equations number 1 and 2. So, let us multiply equation 1 by omega 1 and equation 2 by omega 2 and add. So, that will give us this equation is to be multiplied by omega 2 and this equation to be this equation is to be multiplied by omega 2 and the equation number 1 which is present here, this we are multiplying by omega 1. So, this indicates I times omega 1 times omega 1 dot plus omega 1 omega 2 omega 3 times I 0 minus I plus, now take the equation number 2. So, equation number 2 is here, we multiply it by omega 2. So, I times omega 2 dot times omega 2 plus omega 1 omega 2 omega 3 times I minus I 0, this is equal to 0. So, in this we can see that this term and this term it cancels out. So, these two terms will cancel out, leaving us with I times omega 1 dot plus I times omega 2 times omega 2 dot, this is equal to 0. I we can take it outside because the quantity I is not equal to 0, therefore, we can write as omega 1 times omega 1 dot, and this simply you can recognize that we can write this as and this implies omega 1 square plus omega 2 square, this is a constant and this we can indicate as omega t square. So, what we have concluded till now? So, our conclusion is omega t, this is a constant, means omega 1 square plus omega 2 square under root is equal to omega t, this is a constant, okay, and also omega 3 which we are writing as n, this is also a constant. So, these are two very important conclusions which will give us lot of insight into the equation of motion. So, we go back to our original figure. Okay, so, this body was rotating. So, the body components we have already written here in this place. So, the angular momentum vector, its components can be taken in the body reference frame as h 3 and the another one is here in this place. So, here we indicate this as h 2 h 1, this is h 1, the body x 1 sorry, and here in this direction we have h 3. So, thus we see that okay, moreover what now we have concluded that the vector will make a separate figure for this. Say we have the H3 vector is along the third body x, which is here, and we are getting in this direction the H1 and H3 we have shown as in this. Okay. Omega 3 is in this direction only, and omega 1 is also in this direction, and this is omega 2, and omega 2 is in this direction. Now, what we concluded in our earlier discussion, look into this, what we concluded here. We concluded that omega and h are coplanar. So, we have omega and h. So, omega vector and h vector, they will be coplanar. So, vector composed by omega these components omega 1, omega 2 and omega 3, it will give you some vector, let us say, which is being indicated as this is your omega 1, not omega 1, this is omega, this is your vector. So, in this figure has become very complicated, but what we are trying to represent here, that this is E 1 cap and E 2 cap. These are the two orthogonal axes making 90 degree with each other, and perpendicular to the plane of this is the third axe, which is E 3 cap, which is shown here. Okay. And omega t will lie in the plane constituted by E 1 cap, E 2 cap. This we have seen here while discussing sorry, this figure. Now, omega t and E 3, it constitutes another plane, and in that plane h and omega they are lying. Now, what does it indicate? It indicates that the along the direction E 3 we have the omega 3, okay, and here the omega vector is there, and this is the h vector. So, this simply concludes that omega 3, omega and h, they will lie in the same plane. So, omega 3, omega and h, they are lying in one plane. So, what really happens, again going back to this figure. So, this body is rotating about this, and simultaneously this is precessing about this axe, the vertical axe that we are showing here in this place. Okay. So, it will undergo precession like this. We have to conclude many more things, but still we are in the mid stage right now. So, say this is the main axe along which the psi dot we are showing here, okay, and the body is rotating about this. This is our main axe, and body is rotating about this axe. it is having the spin about this x, okay, and then also it is a precessing around this, it is precessing around this. Okay. So, from here what we conclude that the omega 3, which is the vector omega 3 is the body component of the omega vector. So, omega 3 and the h vector. So, h vector we can always orient with for our convenience with along the E 3 direction. Okay. We can always orient our inertial reference frame such that h coincides with E 3. So, right now suppose that h is along this direction, omega 3 is along this direction, and what we are just now concluded that this omega, which is the vector. So, these three are lying in the same plane. So, if the body is rotating, around this in this way, and also it is spinning on its own axis, okay, like this. So, you can imagine what is happening. This is your h vector, okay, and this is the omega 3 vector is along this direction. Okay. Omega 3 is along this direction, which is lying along the third body x. Okay. And omega is another vector whose component actually the omega 3 is. So, now let us indicate it like this. So, this is your omega vector, this is your h vector, and this is the omega 3, which is representing the spinning the body component of the angular velocity along the third axis. Okay. So, it is rotating like this, okay. And finally, this body is also precessing. So, the omega vector it will precess in this manner. This is your h vector and this is omega vector, this is the omega 3. So, it is precessing like this. Okay. You see here it is suppose it starting in this way. So, it is rotating like this. So, always they are lying in the same plane. This is what we conclude from our mathematical derivations till now we have done. Okay. So, this is our very important conclusion. Okay, once we have done this, so let us consider a case of a disk. This is your omega 3 shown this way. So, it is rotating about this x. Okay. H vector as usual we have indicated along the E 3 direction. So, this is the h vector and this is the E 3 direction. Okay. This is arbitrary. H vector, this is the angular momentum of the body, and if you remember from our earlier lecture that h vector and omega vector in general they do not coincide until unless the rotation of the body is along one of the principal axes. So, only along one of the principal axes. So, here in this case what is happening? We have the h vector here, omega 3 is here in this place, and omega vector is somewhere like this. Okay. So, they are constituting one plane. So, in one plane this angle we have indicated by theta, okay. And let us say the angle from here to here, this is gamma. Okay. So, you have omega 3 here, and omega t is lying in also in the same plane, okay, because we have just now looked earlier that omega is composed of omega t and n. n is nothing but omega 3. So, omega 3 and this is your omega t, they are lying in the same plane. In the same plane your omega vector also lying and h vector is also lying. So, you can see from this place, and this angle we are showing between the angle between omega 3 and omega as gamma, and this is the component we can show as omega t, and this is the component you can show as omega 3. So, tan gamma we can write as omega t by omega 3. Okay. Now, omega t, this implies the omega t is a constant and omega 3 is also a constant. Okay. Therefore, this is a constant. Okay. So, this implies gamma, this is a constant. So, this angle, the angle between omega and omega 3, this remains constant. Similarly, the h we have written as combination of E t in terms of E t and E 3. Okay. Similarly, you can write this angle theta. So, along the third direction we have h 3 and h t is obviously lying in this plane, because h is lying in this plane. So, the component of h t we can write in this direction also, and omega t is also along this direction itself. Okay. So, the same kind of figure we can draw for h t and omega t also, h t h 3 and h and h t. So, we have this angle, this is your theta angle, this is your h 3, okay, and this is h. Okay, now, look from this place. Along this direction you have the h t. So, we can join from here to complete this vector. This constitutes your h t. In this equation what we have done, this is the quantity which is present here, this is nothing but your h t, and b which we have written here, this is nothing but your h 3. We can look back into our old equations. See what is the quantity here. This quantity is nothing but your h 3. Okay. This can be written as, basically h is nothing but h 1 times E 1 cap plus h 2 times E 2 cap plus h 3 times E 3 cap. So, this is your h 3, okay, and this together it constitutes the h t vector. So, this component is h 3 and this is h t, this is obvious, okay, and this be reduced into this form. So, this is your h t and b is your h 3. Okay. So, that is why I told that this result is very important, and based on this the whole structure is based. So, once it is written in this format, you can see from there that tan theta, this is nothing but h t by h 3. Okay. And h t is how much? h t, this we are once we are writing in terms of E t. Okay. So, we can indicate this, see the h t part, this was basically your I times omega 1 E 1 cap plus I times omega 2 E 2 cap, if you remember, okay, what we have done here in this place. Okay. So, taking I outside, this is omega 1 cap omega 1 times E 1 cap plus omega 2 times E 2 cap. So, this is I times, and this is nothing but your omega t cap, omega t vector. So, h t is your I times omega t. So, then the magnitude wise you can write as I times omega t, and what was your h 3? H 3 is already you have written here, this is I 0 times n. So, this is I 0 times n or omega 3 or n. So, now see here, this is a constant, this is a constant, omega t is already a constant, we have proved it, omega 3 this is also a constant. So, all these 4 quantities are constant, therefore, this also implies this is a constant. So, what does it imply? That theta is also a constant. Okay. So, by our conclusion till now, what it is? Gamma this is a constant and theta this is a constant. So, ultimately what conclusion we are drawing, that this angle theta and this angle gamma they remain constant, means if this is your omega 3, this is the omega vector and this is the h vector. Okay. So, this whole plane is rotating like this, but the angle, this angle from here to here, which is the gamma angle, okay, and this angle from here to here, which is the theta angle, both of them they remain constant, means there is no only the plane is rotating, but the position wise there is no difference, position wise there is no change. Okay. They will maintain the same position throughout. So, from our conclusion we can tell that the torque free rotation of a body, once we are taking it, and the body is obviously in this case we are taking such that the body axis is aligned with the principal axis. So, in this case the theta angle it remains constant, the gamma angle remains constant. Later on we will see that the theta angle we can call this, basically we call as the nutation angle. So, nutation angle remain constant, and the body which is rotating like this, this is called the precessing motion. Okay. And this suppose a top is rotating. So, it is rotating like this. So, this is the spinning motion. If the top you disturb it, so it will get tilted, okay, and then it will start doing like this. Okay. So, in that case at least the gravitational motion is acting, but this motion is called the nutation motion, and the rotation which is being done like this is called the precession motion. So, we stop here in this place and we continue in the next lecture. Thank you very much.